There we go. Okay, so we're going to go ahead and build an application that that Ben showed demonstrating earlier. So let me go ahead and clear here, and you can see I'm in a repository, and this is a repository from one of the accelerators that Ben was showing. So let's do ahead and do a Tanzu app workload create -f config workload.yaml. And there was a question previously in the chat that I saw that was asking about how are we preventing walls of YAMLs and how are we mitigating that? And this is one of the ways that we're doing it, right? So you can see this workload.yaml is a configuration file for how I'm going to deploy my workload in the Tanzu application platform. And this is really all you need to worry about. As a developer, as an operator, this is all you care about. So 16 lines of code. And if I remember, I'll show the resulting lines of code that this actually deploys in Kubernetes, and it'll be in the thousands of lines of code, right? So 16 lines is all we care about. So rather than thousands, we're dealing with just the 16. A couple things I want to point out here. Workload type is web, right? So I talked earlier as a challenge of having a significant amount of supply chains that you have to manage. The way that the application platform works is that we're mapping our application to a supply chain, right? We're letting the supply chain identify the application type and opt into that supply chain being run. So here I'm specifying that my application, my Tanzu, what is this, Tanzu Java web app, is a web application. So we're going to run our web supply chain. So let's go ahead and kick that off. And now I'm going to hop over to our application GUI, which is a Backstage-based GUI that we're using with all sorts of plugins. And one of the plugins that we just released is our visualization plugin. So I talked about it being important to be able to see your application as it progresses through. So this is exactly what we're going to walk through. So you can see that we've established a source provider. We're going to test our code using Tekton. It's going to scan that source code for any vulnerabilities. We're then going to build that image using the Tanzu build service, scan the resulting image for any vulnerabilities, and then write out the config. And this is where the convention service comes into play. So it's going to look at the configuration from the image, the bill of materials that I'll show here in a second. And it's going to adapt and apply any conventions that we know for that application that exist and get the Kubernetes configuration deployed, and finally deploy it out and run it in cloud native runtimes. All right, so now that we've seen kind of where we're at, let's hop back into Kubernetes, and we can see exactly what's going on here in detail. So let's just do a kubectl get pods. And we're going to see that there is a testing pod that is already running. Just 1 second here. Okay, so we can see that a test pod has already run. And if I'm just going to do a quick logs on that, and we can see that it built successfully. We had one test run, so it's a very well-tested application, and it passed. So we're going to continue on with the supply chain. So let's go ahead and do a kubectl get pods again, or we can hop back into the supply chain visualization. We can see that the source scanner has already done. So it's pulled down our source code. It's scanned that source code for vulnerabilities. So let's just do a source kget source scan here, and see where we're at. So we can see that our Tanzu Java web app has completed the scan. And we can see that there was no vulnerabilities found, right? So it's continuing on with the supply chain. And I'll dive deeper into that one as we get into the image scan. They're very similar. It's just easier to show one of them, and in the image scan can give you a much better idea. Okay, so now we're on the image build process. So let's do a kp build logs, and we're going to do Tanzu Java web app. And I like to show this because it really kind of illustrates how easy it is to build a container image. So if I was building this application without the Tanzu application platform, I would have to build a Docker file. The way that this is working is the Tanzu build service is looking at the source code, and it's using cloud native build packs. So you can see here that we have 10 out of 23 build packs that are participating. So what has happened here is we have 23 build packs that are part of our platform, and it has looked at the signature on all those build packs and compared it to our source code and identified that these build packs need to be executed against our source code in order to build container layers that then will be assembled to build our resulting container image. So you can see we have a Spring Boot application. It's running on Apache Tomcat, and we're using Maven. So it's going to use all of those cloud native build packs to build our container image so that we don't have to worry about using a Docker file. This is exactly how the image is going to be built. So once it's identified, it's going to run those build packs against it, and we're going to get some resulting layers. Layers are going to all be built here. I've previously built this, so it's just pulling some of them from cache. And then it's going to push it up to my container registry. The important thing here to also see is that we're also signing the container image, right? So we're going to be able to authenticate the source and the validity of that image because it's signed and pushed to our registry. All right, let's hop back and take a look at our image scanner. So our image scanner has completed running successfully. Let's take a look at that. So you can see here with pretty good results here. So we have our application has been scanned. It has zero critical vulnerabilities, 0 high vulnerabilities. I am kind of running out of time. If we wanted to, we push all of this data into our metadata store. So you can actually look at the results of this in a much fine-grained detail from both. You can see what vulnerabilities were found in that image, as well as if you wanted to see all the images that had a specific vulnerability, you would be able to do that as well. So now that we have scanned our container image, we can look at the config provider and the app config. We see that it has scanned the resulting container. So the bill of materials was attached by the Tanzu build service. It was able to identify that it's a Spring Boot application. So it's going to put conventions in for Spring Boot applications and apply those to the Kubernetes configuration. So now that we've done that, let's hop over and we can look at our catalog. So our application has been deployed. It's made it through the full supply chain. So let's go to our Tanzu Java web app and let's take a look at our runtime resources. Ben demoed this a little bit earlier as we were going through in the live update section, but this is basically the catalog for the application. So we can dive into it here. We can see all the metadata about it. We can see routes, Knative revisions. So if you had multiple versions of the applications, you could see how your traffic, how you're load balancing the traffic, whether you're doing AB or Canary or whatever method you're choosing. You can also see the pods that are running. One of the things that I like to show out here, if I refresh it, we should see that pod go down to 0. And the reason that, it's gone down to 0. And the reason is because we're deploying and we're using cloud native deployment models. So we're using a scale to 0 methodology here, right? So because I haven't hit that service at all, it's actually scaled it down to 0. So saving you resources and pods running. So let's go ahead and take a look at our application, make sure that we are up and running. And what you're going to see here is it's going to pause. And the reason that it paused is because in the background, it actually had to spin up a pod. So if I come back here and I do kubectl get pod, we're going to see that we have a new deployment running, and it's only been running for 11 seconds, right? So it's got that, it spun it up because it was a request came in. So the request came into our application platform. It held onto the request until a pod was up and available to serve the request. Then you can see that our application has been deployed. So that walked you through. I hope that I got through all of the challenges. One of the things I really wanted to touch on was the YAML and show how we are abstracting. So, oh yeah, let's go back and do that. So let's do a kget all -o YAML, and we're just going to do wc-l. So we see all of that. And this isn't going to be an exact representation because there's some scan pods in there and stuff like that, but it should give you quite a good idea. So this will tell you exactly how many lines of code are involved in our application. So you can see 3,479 lines of code, which let's just take 1,000 away for some of the extra stuff that we get with the config and the config writer and the build pods. But still, you can see the significant reduction between 16 lines of code all the way out to the 3,500 or 2,500.